No apes are living in North America. But why is this? Did they once roam there? And if so, what happened to them? Firstly, what are apes? Apes are a higher group of primates. They belong to the superfamily Hominidae, which splits into the lesser apes and the great apes. This split occurred around 20 million years ago. 20 species of gibbon belong to the lesser apes, and the great apes include orangutans, gorillas, bonobos, chimpanzees, and, of course, humans. Some use the term monkey and ape interchangeably, but scientifically, this is incorrect. Apes do not have tails, whereas monkeys do. Also, apes are considered more intelligent than monkeys, who have more primitive brains. Apes are generally larger than monkeys, and although most can live in the trees, many spend a lot of their time on the ground. Apes are native to sub-Saharan Africa and Southeast Asia. They once lived in Europe too, but none have ever lived in the Americas. If we travel back roughly 55 million years ago, then we can see the evidence of the first primate-like animals in North Africa. At the time of the first true primates emerging on the global stage, Africa and South America had drifted apart. The separation of these two continents occurred around 120 million years ago. So, the split of these two landmasses happened tens of millions of years before primates even existed. Although there are no non-human apes in North, Central, and South America, there is a variety of primate species inhabiting South and Central America. Primates include monkeys, as well as prosimians such as lemurs and lorises. Each South American primate is adapted to tropical rainforests. They include, but are not limited to, marmosets, capuchins, squirrel monkeys, sakis, spider monkeys, and howler monkeys. Collectively, these primates are known as the New World monkeys. They split from their relatives in Africa approximately 40 million years ago. Those in Africa are known as the Old World monkeys. It is generally accepted that all primates originated in Africa. So, how and when did South America's New World monkeys come to live there? Did any of these primates travel northwards to North America? Recently, scientists found the fossilized teeth of ancient primates in the heart of the Peruvian jungle. The teeth were dated back to 37 million years ago and were analyzed to have come from a lineage of African primates. Around this time in Earth's history, the ice sheets at the poles were formed. More and more sea was locked up as ice, dramatically lowering the sea level. The journey from Africa, across the Atlantic Ocean, to South America was about a quarter of the distance it is now. This would have made the journey slightly easier. The monkeys likely traveled across the open water on vegetation rafts that broke off from the African coastline during storms and drifted out to sea. There is a suggestion that back when the sea levels were lower, there were islands and atolls in the mid-Atlantic, which are now submerged. These could have provided refuge for the primates as they drifted westwards to the New World. The geographical separation of the two groups of primates allowed for evolution in isolation from one another. The New World primates adapted to the environment of South America, and the Old World primates to Africa and Asia. Monkeys developed and evolved in South America's tropical rainforests. For a long time, South America was cut off from the rest of the world. There was no connection between North and South America until the formation of the Panama Land Bridge. Before this, the wildlife in the South evolved in its unique way, similar to island continents such as Australia. But when North and South America became connected via the Isthmus of Panama 4 million years ago, there followed the Great American Biotic Interchange, where species could migrate between the two. Despite this, it seems most primates in South America remained there. They were well adapted to life in the rainforest. They must have had plenty of food and territory, with little competition, because it was rare for them to migrate northwards. Before the formation of Panama, there did seem to be some migration of primates into the north, perhaps by mistake. Crossing the open seas from the south to the north was no mean feat. They would have likely traveled unsuspectingly on floating rafts of vegetation, much the same way they did across the Atlantic from Africa. Scientists have discovered 21 million-year-old fossilized remains of a primate, similar to today's capuchins in North America. It is not known how long these primates lived in North America, though. Likely, they may not have survived long, with few fossils found in Central and North America. It seems that the majority of New World monkeys didn't spread northwards due to the boundary of their rainforest habitat. This constrained them largely to South America and parts of Central America. Even today, they do not inhabit North America. So, we know apes never evolved in the Americas. But what do we know about their evolutionary history? There is always some debate about where apes evolved, but using a combination of molecular, fossil, and biogeographical analysis, scientists believe that the Old World primates, including the lineage that went on to become today's great apes and humans, dispersed from Africa into Europe and Asia 20 million years ago. They then migrated back to Africa 10 million years ago. Although it is generally accepted that apes originated in Africa, if you travel far enough back in time, to around 40 million years during the Eocene, they had a common ancestor in Asia. This was long before apes and monkeys existed, but it was called Afrasiadigitidae. It was a tiny early primate approximately 100 grams, or 3.5 ounces in weight. It is thought that this primate-like animal may have drifted to Africa from Asia over the open seas, much the same way the New World monkeys traveled to South America later on. From Africa, the apes that eventually evolved migrated. The fossil record shows that apes once lived in Europe, although there aren't any native apes living there today. They seem to have evolved in Europe, having migrated from Africa, before returning to Africa. At the time, Europe offered subtropical forests, the right climate, and plentiful food. Apes likely left Europe and returned to Africa during the late Miocene. At this time, Europe's climate changed dramatically. The rise of the Himalayas in Asia resulted in a much cooler and drier European continent, and subtropical forests gave way to deciduous woodland. The only way for apes to survive was to head south, back to Africa. But there is so much more to our ancestor story. Scientists believe that apes split from the Old World monkey lineage around 25 million years ago. Around 20 million years ago, a primate emerged in Central Africa, which is thought to have been the link between monkeys and apes. It was known as proconsul, to which 4 species belonged. Its posture was similar to that of a monkey, but it lacked a tail, had an ape-like facial structure, and had the hand grip of an ape. It is debated whether this animal was the link between the two primates, but regardless, it is classified as the earliest known ape to have existed. Between 9 and 17 million years ago, apes from the genus Dryopithecus were living in both Africa and Asia. It is thought that all modern-day great apes are descended from this genus, and those living in Asia went on to become the orangutans that we know today, whilst those in Africa became the other great apes. While orangutans were evolving in Asia, so too was the largest ape to have ever walked the earth. Gigantopithecus stood at 10 feet, or 3 meters tall, and weighed up to 1,100 pounds, or 500 kilograms. It was a giant. It mostly fed on fruit, and whilst its huge size likely protected it from potential predators, it also led to its demise. As the Earth's climate changed, and the rainforests gave way to savannas, the huge volumes of fruit required for such an animal to survive dried up. They were less able to adapt their diets to take in the roots and shoots of a changing landscape. Furthermore, larger animals tend to have fewer offspring, and so their population size was relatively small compared to smaller primates. Extinction rates increased as body size increases. This is why their relatives, the orangutans, managed to survive while they didn't. The rhino. These mammals are most famous for their characteristic horn, or horns, their thick, armor-like skin, and their huge, stocky build. Today, there are 5 species of rhino. These are the white and black rhinos found in Africa. The Indian rhino is found in India and Nepal, with 1 pair in Pakistan. The tiny population of just 60 Javan rhinos is restricted entirely to Ujung Kulon National Park in Java. And the Sumatran rhino, whose population numbers less than 300 in Sumatra and Borneo. No wild rhinos currently live in North America, but this wasn't always the case. In fact, it is thought that today's rhinos living in Africa and Asia had a common ancestor in America. Scientists believe that rhinos originated in North America before spreading across Eurasia, and then into Africa. In America, the lineage of mammals that eventually evolved into rhinos had a common ancestor with today's tapirs. The name of this common ancestor was Hyraceus. It was a hornless mammal with the hooves of a tapir and teeth of a rhino. It was about the size of a large dog. They lived across North America and Eurasia during the Eocene. Then, approximately 60 million years ago, the superfamily Rhinocerotidae diverged from tapirs, and scientists believe this divergence occurred in either Eurasia or North America. If it was in North America, then that is where the rhino lineage began. From this superfamily of rhino-like mammals, more than 100 species evolved and radiated across Africa, Eurasia, and North and Central America. Most of these species became extinct before the Pleistocene, more than 2.5 million years ago. 9 species survived into the late Pleistocene, and some beyond. Between the many species of prehistoric rhinos, there were significant differences in physical characteristics. Many of the ancient rhinos were actually hornless, and interestingly, there was one rhino native to North America, Menoceros, with 2 horns arranged side by side at the tip of its nose, rather than one in front of the other. The Rhinocerotidae was divided into 3 family groups, which included the Hyracodontidea, Emmenodontinae, and Rhinocerotidae. The Hyracodontidea were horse-like animals that ranged in size from that of a dog to one of the largest mammals ever to have walked the earth. This giant, hornless rhinoceros was called Paraceratherium and stood at almost 5 meters or 16 feet tall at the shoulder. Its fossils have mostly been found across Eurasia, so this particular rhino-like animal was unlikely to have stepped foot on North American soil. The 2 other families included in the superfamily are the hippo-like Amenodontidae and Rhinocerotidae, from which all modern-day rhinos evolved. Fossils from these 2 families have been found across Eurasia and North America. Fossils of Amenodontidae have been found in Eastern Asia, Central Europe, and North America. Some members of this family were hippo-like in appearance and lived a semi-aquatic lifestyle, while others were mostly land-based, with a tapir-like proboscis and small tusks which they used as a defense against predators and rivals. Within Rhinocerotidae, there were at least 26 different genera that inhabited Eurasia and North America. The ancestors of today's rhinos were some of the most widespread mammal groups in North America. They existed there for almost 40 million years. If we focus on just a couple of prehistoric rhinos, we can understand why they became extinct from North America. 2 common genera roaming from Africa's Great Plains were the Teleoceras and Aphelops. These animals lived on the continent 17.5 to 5 million years ago. They were the last known genera of Rhinocerotidae to inhabit North America. Once they became extinct, there is no fossil evidence of Rhinocerotidae found in America. Teleoceras rhinos were similar in size and shape to modern-day hippos, but lived on land. They grazed grasses and brush on the open plains. They had a small horn on the top of their nose and shorter legs than today's rhinos. Their fossils are commonly found throughout the Great Plains, and from these, scientists have had a glimpse into the social structure and behavior of these rhinos. The groups were predominantly female, with males dying at much younger ages. This was due to battles for mates and injuries that occurred from clashes. It is thought that they used their horn and tusk-like teeth to fight. Today, rhinos also fight in this way, inflicting injuries on rival males. The Aphelops was another rhino that also coexisted with Teleoceras in North America. From fossilized dentition and skull morphology, it has been assumed that they were more browsers rather than grazers. They had a prehensile upper lip, similar to today's black rhinos. This enabled them to pick up leaves from trees and shrubs rather than graze on grasses. They had longer limbs than other prehistoric rhinos, suggesting that it was good at running. It is often referred to as the running rhino. It is thought that they lived in herds, probably as a means of protection from predators, like many prey species today. So why did these two genera of prehistoric rhinos become extinct in North America? What happened to them? The answer lies in the food they ate. As the climate naturally changed, so too did the vegetation. These prehistoric rhinos grazed C3 plants. These were the predominant plant species found in North America at the time. The name C3 refers to the 3 carbon compounds produced during carbon fixation. This is a way in which plants utilize carbon to create energy in the form of carbohydrates. Even today, C3 plants are very common. They are most efficient in cool, wet climates. When the climate began to cool and precipitation reduced, the earth became drier. This happened approximately 17 to 14 million years ago during the mid-Miocene. These changes in environmental conditions resulted in a significant shift in the flora. C3 plants gave way to more advanced C4 plants. This flora was able to thrive on less rainfall and, even today, is less common, but still dominates grasslands where there is little rainfall. By 6.5 million years ago, these plants had expanded across the Great Plains. The herbivores that couldn't adapt to a change in their diet struggled to survive as the plant communities and vegetation structure altered. However, the 2 rhinoceros genera Teleoceras and Aphelops initially survived this ecological pressure. They were able to adapt their feeding behaviors and incorporate more C4 vegetation into their diets. Although their numbers declined to about 60% of previous populations, they slowly recovered. But 5 million years ago, their numbers declined once more. This time, they were unable to recover and did not survive. Whilst rhinos became extinct in North America, their relatives continued to live throughout Eurasia and Africa. 16 million years ago, the 2 African species split from the Asian rhinos. It is likely that they traveled down from Eurasia and settled in Africa. The Eurasian lineage gave rise to the Asian rhinos, which included extinct species like Merck's rhinoceros, as well as the more famous woolly rhinoceros. Interestingly, today's Sumatran rhino is the most closely related extant species to the woolly rhino. They diverged from a common ancestor 9.4 million years ago. The woolly rhinoceros was adapted to live in the cold, with its long, shaggy fur, a trait that the Sumatran rhino has partly shared, as it has a thin layer of fur covering its body. Over the millennia, there have been wide and varied members of the rhino family. They have ranged from the size of a dog to a colossal giant standing 16 feet tall. Some have 1 horn, others have 2, and some have none. But their evolutionary journey may yet be over. Researchers from Cambridge University have measured the horns of all 5 extant species from photographs taken over the last 100 years. In all 5 species, there is a significant reduction in their horn sizes over the past century. The team believes this physical change in rhino horn is due to excessive poaching. Those with the largest horns are huge targets for poachers. Rhino horns fetch a huge price on the black market and are still used in traditional medicine in China and Vietnam. The smaller horned rhinos that aren't hunted therefore survive and pass their small horn genes down to the next generation. From some of the most abundant species on the planet to some of the most critically endangered, rhinos have had an interesting and varied evolutionary history. And it would be incredible if we could keep these fascinating animals alive for future generations to enjoy. The proverbial king of beasts. The lion has been one of the best-known wild animals since earliest times. There are 2 types of lion subspecies. One is named Panthera leo melanocata and lives across South and East Africa. The second lion subspecies has the scientific name Panther leo and lives in West Africa, Central Africa, and Asia. Today, lions have been pushed into more isolated pockets of their once vast natural range, with the remaining African lion population now found only in sub-Saharan African countries. In India, a small population of Asiatic lions can still be found in a remote part of the Gir forest. Despite their dwindling numbers, lions are actually incredibly adaptable animals that can and will inhabit very dry climates as they get most of the moisture they need from their food. They prefer areas of open woodland, scrub, and long grasslands, where there is not only plenty of cover, but also a wide variety of prey. They are only not found in areas of rainforest or far into deserts. As you can see, North America is not on the list of places where lions live, but things have been different in the past. During the Pleistocene epoch, lions lived in Africa, Europe, Asia, and North America, giving them one of the largest ranges of any animal. The lions that lived in North America were called American lions. For paleontologists, these lions are a source of debate. Their classification and how they are related to other big cats is uncertain. Recent genetics suggest that American lions evolved from Eurasian cave lions that crossed the Beringia land bridge into North America. Atrox, in the lion's scientific name Panthera leo-atrox, means cruel or frightful in Latin. And from what we can tell, this certainly describes American lions. Standing at almost 4 feet, or 1.2 meters tall at the shoulder, almost 8 feet, or 2.5 meters long, and over 500 pounds, or 230 kilograms in weight, American lions were bigger than modern lions. They had long, slender legs with retractable claws, and they could roar. Although it is not certain if American lions had manes or not, their large size and bulk, sharp teeth and claws, and long legs would have made them a frightful sight indeed. These long legs would have made American lions formidable hunters as well. Similar to modern lions, long legs would have allowed American lions to sprint very fast, possibly up to 30 miles, almost 50 kilometers per hour. However, it is probable that they could not sprint for long periods and had to rely on ambushes. Being a carnivore, American lions would have probably hunted various other Pleistocene animals, such as horses, deer, camels, ground sloths, young mammoths, and bison. They might have hunted and lived alone or in small prides, kind of like modern lions. Whether the American lion hunted by itself or in groups, it must have been successful. During their time walking the earth, American lions walked themselves all across North America. Fossils have been found from Canada to as far south as Chiapas, Mexico. It was generally not found in the same area as the jaguar, which favored forests over open habitats. It was absent from eastern Canada in the northeastern United States, perhaps due to the presence of dense boreal forests in the region. American lions roamed across North America for thousands of years. Around 10,000 years ago, however, they went extinct, alongside a lot of other Pleistocene megafaunas. The exact reasons are unknown. Their extinction may have been due to human interference, humans hunting the prey American lions relied on, climate change, or both. Whatever the cause, the reign of the lions in North America came to an end. Today, these animals are still studied and imagined through the clues they left behind. Today, there are no elephants living in North America. They are currently only found in Africa and Asia, but they did once roam America. So, what happened to them, and how did they get to North America in the first place? If we could travel back millions of years, then we would see the development and evolution of the proboscideans, or elephant-related animals. These developed in a world with a significantly different climate and geography from today. The proboscideans were incredibly adaptive and evolved along with the transformation of the planet. Elephant evolution began some 50 or 60 million years ago. The first creature was a small pig-sized herbivore with a long, flexible nose. With the appearance of open landscapes came significant evolution of the elephant's ancestors. Changes in atmospheric gases led to changes in vegetation and grasses. In return, the dentition of many herbivores, including early elephant-like species, evolved to enable the animals to consume these plants. About 3.2 million years ago, there was a big dispersal of elephant-like ancestors from Africa. Mammoths traveled to northern Eurasia, and Elephas planifrons traveled to the Indian subcontinent. 2.6 million years ago, glaciation occurred in the northern continents and sea levels dropped. This enabled animals to cross intercontinentally between Europe and North America. The mammoths migrated from Europe to North America around this time. Some of the early proboscideans, or elephant-related animals, dispersed from North America to South America during the formation of the Panama Land Bridge. It seems these migrations were driven by food availability, which was influenced by fluctuating climatic conditions. Towards the end of the Ice Age, approximately 12,000 years ago, there were 3 species of elephant living in North America. The Columbian mammoth was the largest, standing at 13 feet tall and weighing up to 10 tons. These ginormous animals were most closely related to today's Asian elephants, which, in comparison, typically just stand under 7 to 10 feet tall and weigh 2.5 to 5 tons. The other 2 species living in North America during the Ice Age and into the Holocene were the mastodon and gomphothere. These prehistoric elephants were smaller than the mammoth and stood at 10 feet tall and weighed up to 7 tons. Fossil evidence has shown these animals to have roamed over a wide geographical area, both in the Americas and Eurasia. We know that elephants, in the form of woolly mammoths, mastodon, and gomphotheres once lived in North America, but why are they no longer found there? There are several theories about why elephants and their relatives became extinct in North America some 10,000 years ago. There was an unexplained extinction event that took place at the end of the Ice Age, as the planet entered the warmer Holocene era. This event saw the extinction of woolly mammoths, saber-toothed cats, giant ground sloths, cave bears, and dire wolves. There have been 5 mass extinction events that we know of during the Earth's history. The most recent of these was the infamous extinction of the dinosaurs. The loss of much of the megafauna at the end of the last Ice Age is not considered a mass extinction event because there were only about 35 large animal species that became extinct. This is in comparison to 96% of the entire Earth species that disappeared 251 million years ago. This was the biggest mass extinction event in the Earth's history. The first theory as to why mammoths, gomphotheres, and mastodons disappeared is that early human settlers are to blame. These people who made the perilous journey into North America are known as the Clovis people. Some fossils of the huge animals of that time have wounds apparently inflicted by spears. Developing tools that could be fired from a distance at large, slow-moving animals like the mammoths gave these people an advantage. It is thought that the Clovis people hunted the mammoths and their relatives to extinction. In turn, this led to the extinction of apex predators, which had relied on such prey species to survive. Within 1,000 years, the Clovis people had spread across North and South America, from Alaska all the way down to the southern tip of South America. Although humans almost certainly altered the flora and fauna in North America, there is some doubt that they would have caused the extinction of so many animals. Bison are a species that are still alive in North America today. They are herbivores that once roamed the open plains of North America in their millions. They were known to have been hunted by people, and yet they were not hunted to extinction as the theory suggests happened to other prehistoric animals. However, because the mammoths, gomphotheres, and mastodons had incredibly slow reproduction, maybe their birth rate became lower than their death rate. The second extinction theory is related to climate change. The Earth's climate towards the end of the Ice Age began warming up and entering the temperatures found today. An increase in air temperatures, melting of glaciers, and rising sea levels all influenced the animals and plants living on the planet at the time. But there had been previous ice ages. The megafauna that went extinct during the last Ice Age had survived previous fluctuations in climate. Scientists think that climate change this time was rapid. Species struggled to adapt to the change. In the case of the elephant's ancestors roaming North America, it is thought they struggled for food. With the changing climate and reduction in the ice caps, North America developed distant seasons. Not only did this lead to the boom of vegetation during summer months and bust during winter months, but the grass species changed too. Some grasses evolved in response to the changing climate and became less nutritious for the mammoths, gomphotheres, and mastodon. As a result, these giant herbivores died out. A third theory is that the disease carried by the Clovis people could have spread to the wildlife of North America. Wild dogs, rats, birds, and insects, which arrived with the first settlers, could have carried harmful microorganisms to the native animals. Although there is currently little evidence of this theory, scientists are looking into it as a possibility. A fourth theory: most recently, there has been the suggestion of an extraterrestrial cause for extinction. In 2019, evidence was found of an asteroid strike in South Carolina, Pennsylvania, and Greenland 13,000 years ago. Elevated levels of iridium and platinum were recorded. It has been suggested that the impact caused by a mini ice age, severely disrupting the warming climate, and flora and fauna trying to adapt to it. Today, scientists and conservationists are discussing the possibility of reintroducing elephants to North America. Would this be a good idea or not? Introducing a previously extinct species to a habitat will alter that habitat significantly. It would have an impact on the native flora and fauna. It would affect the ecosystem and potentially affect the lives of people living within close proximity to elephant reserves. Elephants are a keystone species. This means that they have such an influence within the ecosystem that their removal would have significant consequences throughout the food web. The destruction that elephants cause by killing trees and plundering farmland has been widely reported. Although in some areas, elephants are considered a nuisance, they can be incredibly beneficial to the ecosystem. Devouring acacia trees, stripping their bark, and knocking them over kills the trees. Elephants reduce woodland and open up grassland. Instead of the fast-growing acacia trees dominating the habitat, a wide variety of grasses, bushes, and trees can grow. This, in turn, creates an environment with a greater and more productive mix of browsers and grazers. The biodiversity of both plants and animals is greater where elephants are allowed to roam. Ecologists think that elephants would do well in certain regions of North America. There are areas in the West that are overrun with shrubs and small trees, which would benefit from elephant populations. Biological sciences professor David Burney says that tracts of Nevada, Arizona, and New Mexico containing vast areas of remote grassland could be ideal habitats for the introduced elephants. It is an ongoing debate. Should we reintroduce a species that once lived in North America, or should we focus on trying to preserve the species we already have there? In the wild, speed is crucial for survival. But speed is not a problem for a cheetah, which is the fastest land animal in the world. Globally, cheetahs are famed for their running prowess and strength. Aside from their speed, there are more admirable facts that you should know about this big wild cat. Cheetahs have slender, long-legged bodies with blunt, semi-retractable claws. Their heads are small, with high-set eyes. A black tear mark runs from the inner corner of each eye down to the mouth. A cheetah's teeth are small when compared with other big cats, which accommodates their larger nasal passages that enable air intake. Cheetah's spots may serve as camouflage for both hunting and hiding. Their spots may offset the shadows in the gray-hued grasses they often inhabit, allowing them to blend in with their surroundings. Camouflage is essential not only for stalking prey, but also for protecting cheetah cubs from predators. A cheetah cub's smoky gray mantle may serve as added camouflage among dead grasses. Much like a human fingerprint, a cheetah's spots and the ring pattern of its tail are unique, enabling researchers in the field to identify individuals. Cheetahs are made for sprinting. Their slender, streamlined body allows fast runs, and their flexible spine and long legs enable the cat to take big strides. They also have oversized lungs, hearts, and breathing passages, so they're able to pump more oxygen during runs. Their long tail acts as a counterbalance when running, and semi-retractable claws enable better traction during sprints. Body lengths of cheetahs range from 1.1 to 1.5 meters, or 3.9 to 4.9 feet. Tail lengths are between 60 and 80 centimeters, or 2 to 2.6 feet, and the height at the shoulder ranges from 67 to 94 centimeters, or 2.2 to 3.1 feet. Their weights average from 21 to 72 kilograms, or 46 to 158 pounds, with the average male larger than the average female. The cheetah is an animal that once had a vast historical range that stretched across several continents, but their distribution today is much more scattered, with a small number found in Iran and the majority found in sub-Saharan Africa. Although cheetahs are still found in a few different parts of eastern and southern Africa, the highest population of wild cheetah is now found in Namibia in southwestern Africa. Cheetahs are most commonly found stalking prey on the vast, open grasslands, but they are also found in a variety of other habitats as well, including deserts, dense vegetation, and mountainous terrain, providing that there are adequate supplies of food and water. Cheetahs are one of Africa's most vulnerable felines, with population numbers being mainly affected by growing human settlements that encroach on their native habitats. The pronghorn antelope of North America is one of the fastest land animals on the planet, able to reach speeds of 100 kilometers per hour for short bursts and 40 to 50 kilometers an hour over long distances. Why does it need such a turn of speed? There are no American predators that can sprint anywhere near fast enough to catch an adult pronghorn in a straight pursuit. Well, there aren't any today. Some scientists believe that the pronghorns evolved to run so quickly as a way of evading an American cat that evolved along the same lines as the African cheetah, or Echinonex jubatus, a slender feline built for speed. This was the American cheetah. The idea of a cheetah-like animal sprinting after pronghorns on the American Great Plains seems far-fetched, but prehistoric America was a very different place from the place we know today. Remains of this sprinting cat are exceedingly rare, which is what you would expect for a light, slender-boned animal that was probably uncommon. With that said, the discoveries we have to allow us to reconstruct what this animal may have looked like and how it may have lived. The bones of this animal were found in Natural Trap Cave, Wyoming, a big hole in the ground where lots of prehistoric beasts met an unfortunate end, and Crypt Cave, Nevada. Up until the late 1970s, these bones were considered to be the remains of puma-like cats. But when some experts had a really close look at the bones, it was obvious that the cat in question was no puma. Like the modern-day cheetah, its skull had a very short muzzle, which gave it a rounded appearance, and the nasal cavities were very large. In the cheetah, these enlarged nasal cavities allow the animal to suck in big lungfuls of air during and after high-speed chases. The similarities also extend to dentition, as the modern cheetah has an interesting arrangement of cheek teeth, allowing the upper and lower sets to act like a single set of meat shears. As the skull of the extinct American cat had the same characteristics, we can assume it had the same predatory lifestyle as the cheetah, a hunting strategy dependent on the high-speed pursuit of fast-moving prey. Thanks to its big cheek shears, the African cheetah is one of the only cats that routinely eats bones, normally parts of ribs and vertebrae. As the American cheetah's teeth are so similar, it may have done the same. It is true to say that the skeletons of the long-dead American cheetah and the African cheetah are very similar, but there are some key differences, and one of the most obvious is size. On average, a fully grown African cheetah is around 67 kilograms. Using the skeleton of the American cheetah as a guide, this extinct animal may have been more like 80 kilograms. Also, the claws of the modern cheetah are completely non-retractable, a feature that gives the cat a good grip when it is pursuing prey. The claws of the American cheetah could be fully retracted, which has led to the suggestion that this cat may not have been as specialized as the fast-running African feline we know today. The forelimbs of the American cheetah are also sturdier than today's cheetah, and they were sheathed in bigger muscles. Greater strength in the upper body, an interesting arrangement of the bones in the lower hind limbs, and retractable claws suggest that this animal may have been able to climb trees, something that today's cheetah definitely cannot do. However, these differences aside, so much of the American cheetah's skeleton is similar to the modern cheetah that it is very reasonable to assume these animals had very similar lifestyles. How was the American cheetah related to the African cheetah? You would assume that being so similar, the American cheetah and the living African cheetah would be very closely related, and it has been argued that the American cheetah could have crossed the Bering Land Bridge into Asia, eventually arriving in Africa and spawning the cheetah we know today. However, nature is never that simple. and it is much more likely that these similarities arose due to the process of convergent evolution, the phenomenon by which two unrelated species end up resembling one another because they adapt to similar circumstances. Fortunately for the pronghorn antelope, the American cheetah died out around 10,000 years ago. Its extinction coincides with the disappearance of many North American mammals, but what factors ultimately led to the demise of this feline are more of a mystery. Climate change was obviously a factor, and the loss of some of its prey species may have also been important. It is possible that such a specialist cat really felt the squeeze of climate change and the effect it had on its environment. The puma, a generalist predator, is still with us today, but the American cheetah was more of a one-trick cat that survived by using speed to catch a small selection of prey animals. In today's big cats, we can see the price of extreme specialization, as the living cheetah is becoming increasingly endangered as its habitats is squeezed ever harder by human activities. That's all for today. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. You can also leave a comment with what you would like to see in the following videos. Thanks for watching. See you next time.